Now, as we discussed earlier, there are kind of three techniques used for lighting. One is actually having dynamically generated shadows, so shadows that are generated on the fly. One is to use the vertices to paint in areas where there'll be shadow, and one is to use paint the shadow into textures. Now, by default, UDK makes every single static mesh use a light map. So if I just say select the table model here and double click, you'll see that in a setup here we have light map coordinate index set to 1 and light map resolution set to 32. Now when this is set to 1, that means it's using a light map. If it's set to 0, that means it isn't. So if that's set to 1, that means it is using a light map, and the light map resolution there defines the size of the texture. So you can see that texture is 32 by 32 pixels. So straight away let's just try increasing that. Now the other thing that UDK does with light maps is it doesn't use the original UVs you set up in Max. It uses a different UV channel to do that. Now you can actually set that up in UDK. So let's just try that. So if we go to Mesh, Generate Unique UVs, and pull this down until you can see the Apply button, and just hit Apply, and then go View UV Overlay. That's the UVs it's generated to for our light map. So let's shut that down and try doing build lighting. Well, in fact, we'll probably need to build all. Now one thing you actually notice here is that for all our other models, except for the table, we're getting this error saying has invalid light map coordinate index. Now the reason it's saying that is it's trying to generate a light map for each of these models, but it's saying basically they don't have the UVs available to generate the light map. So let's have a look at the table now. Already we can see we're starting to get a shadow on the actual table and on the sphere from this light. So already we can see we've massively improved our lighting calculation by adding second UVs. So let's try doing that on each model. First of all, increasing our light map resolution, and then by going to Generate Unique UVs and hitting Apply. And then we do View UV Overlay, and you can see the UVs it's generated. So you can see from it doesn't really work that well. I mean, if you can try tweaking the settings a bit, see if that makes a difference. But you know, you are pretty restricted in what you can do. So you can imagine that when this comes to a kind of complex model, it doesn't work particularly well. So let's just apply this to each model anyway. And make sure that we set our light map resolution size here. I think I forgot to do that one. I did. So I'm just setting them to 256, generate unique UVs, hit apply. And the last wall here. Okay, so let's try building lighting again, and we should find that we get better shadows cast on the floor and up here. But we'll also find that the build of our scene takes a lot longer. And there you go, you can see we're getting a much better shadow approximation now that we've changed the light map settings. Now you'll notice that what's happening here is we're getting this big kind of strafing effect as the light falls off. Now that's to do with our global illumination. So if we come over to view, well, we do it from within the light. So double click on the light settings and try just turning down the amount of indirect illumination you have. And then we'll build our lighting again. And we'll also change the build quality to medium. And you'll see we're starting to get a better effect on this now. Getting a nice shadow on the table. We're getting this nice kind of rise up the wall there. Now what if you did have a more complex model where the UVs it generates in UDK don't really work very well? Well, you can actually set up your own ones in 3ds Max. So we're just going to pop back to 3ds Max just to show you how to do that. So we'll do this on our table here. Now if we add an unwrap modifier on top, now the default map channel is 1, and in UDK our lighting UVs are set to map channel 2. So all you need to do is set that to 2 and make sure you select move if you have UVs already, and then in Open UV Editor you need to make sure you have nothing overlapping in this window. So I'm just going to move each one of these out of here to make sure they're not overlapping at all. And that'll do. So although we've changed the UV channels on map channel 1, if we come down here to our map channel 2, we come back down to map channel 1, you'll see those UVs have stayed the same. So your light map UVs can be completely different to your texture UVs. I'm going to save over TA table. Then in UDK, just re-import. And then if we just build all again, there you go. You can see we've generated those in Max and we've got a better result out of it. And the reason for that is because if we go to select on our model and go UV overlay, you can see it's a much kind of better UV layout than the one that UDK tried to guesstimate for us. So although UDK can generate your second UVs, it can be much better to actually do them in 3ds Max. You can see there we've got that line going across there on this model. I do find in content browser, TA wall side L, if I do my own UVs, I'm sure I can get a better result. So you just drop the unwrap on top, set it to map channel 2, so you know map channel 2 is our lighting channel. Go to OpenUV editor, and actually they should be fine because none of them are overlapping, although you do need to make sure you've got padding between islands, so just a couple of pixels, so that might be a little problem, we'll soon see. And then export selected. Let's make sure that's actually done, and then re-import static mesh and rebuild. And we can see now that line is gone. And there's another problem with that one as well, actually. So pretty much you end up finding that you do most of your second UV unwrapping, you just do it in max rather than using the UDK default one. Now one more thing as well, actually, if you look at those you can see we've got this kind of jagged edge on here that doesn't look ideal, but that's because we're using this white material. So let's just try applying something like this floor to each surface, and you'll see that once you've actually got a material on each model, you can't really see that jagged surface, so don't worry too much about having problems like that. And one we can actually see is that one there, so we should really re-unwrap that in 3ds Max. Okay, so that covers light maps. So just to recap, if I double click on my static mesh, you'll see I can set my light map resolution here, and to be fair, 256 is reasonably high for a model of that size. You can go all the way up to 1024. If that's set to 1, that means it's using a light map, but if it's set to 0, it's using vertex lighting. Now you would use vertex lighting on a small object, like if that sphere was a separate model, I would definitely use vertex lighting on that. It's worth just testing vertex lighting. Why don't we do that now? In fact, I'm going to reapply this material to each model in our scene. You can see there again where the light map is broken. Then we're going to select this one here, and this time I'm going to change that to 0. Let's try generating that again, and we'll just see how the vertex lighting looks on that model. Now vertex lighting is a lot faster than light maps, so it's really worth using. If you've got any small props in your scene, then it's definitely worth using it. So you can see the result there is not bad at all. Though we have problems here though, don't we? So it hasn't really worked very well on that model, but it's worth testing on each of your models to see if it works, because if it does work, it will save you a lot of kind of messing about with UVs and kind of time processing. Let's just change that back to 1. So yeah, the important things to remember here: set your light map coordinate here, increase your light map resolution, and you'll need another UV set of UVs specifically for lighting. You can either do those by going to generate unique UVs in UDK, or in Max you can add a new unwrap, set it to 2, and just make sure that nothing overlaps. Okay, so the next thing we're going to look at then is some of the lighting parameters in UDK. So real quick before I do that, I'm just going to re-export this model and re-export my floor with proper second UVs. Now because we instanced these earlier, we only need to actually do one. Yeah, that should be okay. So re-export this floor. And we'll re-export the ceiling. And there we go. Now if I come back into UDK and just re-import each model, then we're all ready to go. Okay, so just going to leave that light source in there for now, but we're going to first look at all the different types of light sources we have. So in actual fact, let's delete that light source. Come over to our content browser and select Active Classes and go to Lights. Now you see we've got directional lights, point lights, skylights and spotlights. Now you don't need to worry about skylights, don't really need to use those at all, because they're just an old system that was there before lightmass. So the first thing we'll look at is directional light. We'll select dominant directional light and right click and do add dominant directional light. If you use spacebar, you can actually switch between move, rotate and scale. Now this is basically a light source that shines from everywhere in this direction. So it doesn't matter where this is positioned. If I move this up and down, you'll see the lighting doesn't change. It's just light being shot from this direction from every single point. So basically what we'll have is tons of light coming in from this window, from this angle. Now when you select something that's a dominant light in any of these, in point light you see we've got dominant, spotlight you've got dominant as well. That means it's using light mass, which is basically UDK's version of global illumination. So let's just try building this now with our directional light source. So you can see what's happened is we've had light coming in from this direction. It's cast all the shadows on the floor, and then the light has actually bounced up around the room to get all the light on here. Now one thing I do tend to find with UDK is it has its light mass set pretty high by default. So if we just double click on this light, try putting your indirect lighting strength down to something like 0.2, and then just try baking that again. You'll see you now get that darker area around the room. Let's just have a look at how that looks when we run around it. Okay, so you can see it's quite a nice lighting setup that we have. So we're still getting issues on that wall. I must have not imported it correctly. Let's have a quick look at that one wall. Ah yeah, you can see for that one wall I haven't done the second UVs. So I'm just going to apply another unwrap, set it to 2, go to move, and again that should be fine. So export, selected, come back into UDK, and re-import that mesh. Okay, so we'll build everything again. And there we have it. Got a nice kind of light setup, just using our one dominant light here. Okay, so the next thing we're going to look at then is the other types of light. So we've looked at directional light, and we know that's a light source that will, based on the direction of the light, the direction this arrow is facing, it will shoot light from that direction from all points. So if you move it up and down, it's not going to affect the lighting at all. In fact, if you move it left to right, it won't change the lighting at all. It'll only change if you rotate. Remember, it's spacebar to switch between your different things. So this time we're going to look at spotlight. Now just selecting point light. Sorry, this time we're going to look at point light. So this time select point light from the list and add a point light into your scene. Now if we double click it, I'm just going to try setting our radius down to 128. So you'll see what you have is you've got this is basically a light that emits light in all directions. Now you see you've got one sphere gizmo around here and a smaller one inside a yellow one. Now this one is the radius of how far the light emits out before it dies, and this yellow one is actually the light source itself, and that's defined in your light source radius here. So let's try increasing that to 128, all down to 16. We'll leave it on 32 for now. So I'm going to just increase that right down to there, and depending on where this light is positioned, it will completely affect what happens to this light. The two lights will have a direct effect on each other. So I'm just going to position it there, and you'll see we should get some slight shadow falling off there. And obviously in your light settings you can change your light colour, so we can have a kind of more yellow light happening here. You'll notice that in shadows you've got different types of shadows. Now really for this particular project nearly all of your lights will be casting static shadows, and that means shadows that aren't going to move. So like this light source isn't going to move, and neither is this one. So all these lights can be baked in. Now if you're using a dynamic shadow, that means if the light moves, then this shadow will update. Now they're very expensive to calculate, and also they can't really work with light mass, so you don't get that nice kind of blurred edge that you get off a static shadow. Other things I'm sure you'll like are render light shafts. Everybody likes that. Nice little post-processing effect. Now other useful little light settings are, if we go to view, and then world properties, you'll see we have light mass user global illumination, which we definitely want to use, but we also have a use ambient occlusion tab. If you try turning that on, you'll see the darker area, the areas like this will get darker. Now I tend to leave that off, but it can work well for certain scenes. Okay, so let's just try building that now. And you'll see now that we're getting that light shadow being cast from the light source over here. Hopefully you can see that on the video. But you can see we're getting that nice kind of blurred edge on each model from the light mass as well. Okay, so that's a point light. It's basically a light that radiates light from all different angles. So we'll delete that light out, and then the last light we're going to look at is a spotlight. So we'll add a spotlight into this scene. It's pretty kind of self-explanatory. It's a light that has a light cone on it. Just rotate this around so it's having some effect on this scene here. So again, with the spotlight you have the same thing. You can render light shafts from this light as well. You can set the cone angle here and the inner cone angle, so you can have a really thin kind of beam of light like so. You can set the types of shadows. Obviously, as I mentioned before, static shadows is really the most important one. And in fact, you can actually set the quality of the shadows here, so you can do modulate better and shadow filter quality high to actually get a better interpretation of shadows. Again, obviously that takes longer to calculate. So you can set your light colour again, and you can set the brightness of it here. Okay, so let's calculate our lighting again. And there you go, because our light was set to a very strong brightness, you can see it's affecting the shadow on here a lot more. That shadow is now a lot stronger. And we're getting the nice kind of light bounce into this sphere as well. Okay, so the last thing we're going to look at then is using dominant shadows. Dynamic shadows. So this is shadows that can update in real time. So we're just going to delete out that light source again, and we'll delete out that one as well. And we're going to add just a basic spotlight into this scene. I'll rotate this round. And basically the shadows that you can see in the viewport as you rotate when it's not being baked, they're what the dynamic shadows will look like. So you can see they're not getting any fall off, they're not really realistic shadows at all. They don't have that global illumination parameter applied, so no matter how far away you made this light, you'd always get that sharp edge on the shadows. Now actually I've done something a little bit wrong here. Basically, whenever you want to use dynamic shadows, you can select from this list movable and toggleable, because a movable light basically refers to a light that you're going to animate, so move around like that. A toggleable light refers to a light that's going to switch on and off or kind of change its brightness up and down. So obviously that's why they need to use dynamic shadows. Now you can set this up in UDK with a light like this anyway, so I'll just show you how to do that. You can see at the moment we've got cast static shadows ticked on. If we turn that off and turn on cast dynamic shadows, then that will now work. Well, that will be casting dynamic shadows, but it won't work straight away. And for that, the annoying thing is you need to set your light shadow mode to normal. And if that still isn't working, then you delete it out and you select a movable spotlight and plonk that in the scene instead. So then we scroll down in our options, turn off cast static shadows, leave on cast dynamic, and set our shadow mode to normal. And now you see we're getting those shadows cast. So yeah, so if you want to use dynamic shadows, if you can have a light swinging, or a light turning on and off, or a light just moving around up and down like that, you need to make sure you select movable or toggleable, turn off cast static shadows, turn on cast dynamic shadows, and set your light shadow mode to normal. Now you can't have numerous dynamic lights in UDK. I think the maximum you can have is 4, but obviously they're very taxing on the engine. Let's just try building that anyway so you can see what the shadows look like. There you go, you can see it's not casting light mass. It's only casting dynamic shadows and it's not using light mass. One way people get around that, if you do want to have light mass, is by just adding in a point light with a low value, just where near this light to add in, to get that kind of bounce light that you get from the light mass. Okay, so that's pretty much lighting in UDK. You've got your different types of light, directional, point, and spot. If you can use a directional light, make sure it's a dominant directional light. Once you've got your dominant directional light, use different point lights for your small light sources, or different spotlights. And you're pretty much there. If you're going to have a moving light, or a light that changes its brightness, use movable or toggleable. And obviously you need to set up your light maps for each of your models in UDK.